Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be comparing and ordering real numbers. Now, when comparing real numbers, we must be aware that between any two real numbers is another real number. So to compare and order real numbers, you can approximate each number as a decimal, and then use inequality symbols to describe the relationship between each number. Now, the two inequality symbols that we're going to use to compare today are greater than and less than. So this is how we'll be comparing two real numbers. So in example 1, it says use an inequality symbol to compare each set of numbers. So what you want to do first is rewrite the decimal equivalent for each number given. So in problem A, we have 28 over 5 and 2 pi that we're comparing. So I'm going to come over to my calculator and I want to get the decimal approximation for both these numbers. Okay, so this is 5, and I'll just round, or I'm sorry, it was a terminating decimal, so 5.6. 2 pi is irrational, so I need to round it, and I will round it to 6.3. It's closer to 6.3. So we want to compare these. So what we want to say is 5.6 greater than or is it less than? And obviously 5.6 is less than 6.3. So 28 over 5 is less than 2 pi. All right, our next problem, we have pi squared compared to square root 34. So again, I'll begin by using my calculator to get a decimal approximation. Now I'm going to have to round this 9.86960 because it's an irrational number. So I'm going to round it to 9.9. And then square root 34, which is also an irrational number, I'll round it to 5.8. So now we ask ourselves the question, is 9.9 greater than 5.8 or is it less than 5.8? And it is obviously greater than 5.8. So pi squared is greater than square root 34. Now, 22%. Now, if you remember from previous grades, the way you get a decimal equivalent of the percentage is just to move the decimal place back to the left 2 units. So this decimal approximation would be 0.22. Now, 3/8 we'll put into our calculator. 3 divided by 8 gives me a decimal approximation of, I'll round it to 0.4. So now what we want to decide is 0.22 greater than 0.4 or is it less than 0.4? And we know that it is less than. So 22% is smaller than 3/8. All right. Problem D. The square root of 12.25 compared to 37 divided by square root 144. So I'm going to approximate these. Square root of 12.25. Okay, it's a terminating decimal, so it's rational, 3.5. And then we have 37 divided by square root 144. And that would approximate to, say, 3.1. So what we want to do is decide, is 3.5 greater than 3.1 or is 3.5 less than 3.1? And it is definitely greater. So the square root of 12.25 is greater than 37 over square root 144. Example 2, an inequality is shown below. 1/8 is less than x, which is less than 18%. Which values of x make the inequality true? Circle all that apply. So first thing we want to do is convert these two numbers to decimals. So let's say 1/8 is 1 divided by 8. So that would be 0.125 is less than some number, which is less than. And we said for a percentage, move the decimal 2 places to the left. So that would be 0.18. So notice they both start, let's see, I want to underline decimals. Notice they both start with 0.1s. Okay, so our answer has to be in between these two numbers. All right, so let's start with 19 over 3. I want to approximate 19 over 3 on my calculator. So I'm going to come over here, put 19 divided by 3, and that gives me 6, approximately 6.3. That is, there's no way 6.3 is between 0.125 and 0.18. So not going to be A. All right, B, 1.6. Still, that's way too big. Okay, 0.09. No, not big enough. All right, 4.7. Nope, too big. And so we hope it's going to be E. So let's type it in. Square root of 0.02. And we get 0.141. And that is definitely between. So answer E was the only one that was between 1/8 and 18%. Now, when we're ordering real numbers, we can put them in order from either least to greatest or greatest to least. So we begin by finding a decimal approximation for each number, and then we plot them on a number line to visualize their order. So look at example 3. Place the set of numbers below in order from greatest to least, and then they've given us a set of 4 numbers. Now, before we start, I'm just going to, because a lot of times people forget, we want the greatest to go first in this problem and the smallest or the least number to go last. So I'm going to go ahead and label that so that once we put them all on the number line, we won't forget. All right. So we have, first thing we want to do is take each number and turn it into a decimal if it's not already a decimal. So negative 0.3 is already a decimal. And then we're going to get 5 over 2. 5 divided by 2. This is 2.5. Now we need square root 3. Square root 3. I'll round that to say 1.7. And then negative 4 over 3. So negative 4 divided by 3. Negative 1.3. All right, now let's put these on the number line. The first one, negative 0.43. So here's 0. It's negative, so we're going to go to the left. And we want to go pretty, this would be negative 0.5. So negative 0.43 would be about right here, and I'll label it. Almost to the negative 0.5. All right, 5 over 2 is 2.5. So I will label this 5 over 2. It's right here at 2.5. All right, 1.7. Now, this would be 1.5. So 1.7 is a little bit bigger than that. So I'm going to put square root 3 about right there. Negative 4 over 3 is negative 1.3. So here's negative 1.5. So we don't want to go, we want to go past negative 1, but not all the way to the negative 1.5. So maybe like right there, that would be negative 4 over 3. Now, once you get all the numbers on the number line, then you can clearly see which one is the smallest and which one is the biggest. So they want the greatest to come first. So that was 5 over 2. And then the next one was square root 3. And then negative 0.43. And then negative 4 over 3. All right, example 4. Which list shows these numbers in order from least to greatest? So small to big. Okay. All right, so again, the first thing you want to do is get a decimal approximation for each number. So we have square root 38, square root 38, and that would be approximately 6.2. Okay. Next one, negative 6.35 is already a decimal. 63%. So remember, move your decimal 2 places to the left. So 0.63. And then negative 19 over 3. negative 6.33. All right, now we want the smallest one to come first. So the smallest one is going to be a negative number here. So I want to go ahead and get rid of answer B. So our smallest one has to be a negative. Now our largest number is going to be square root 38. So I can now get rid of answer C. All right. Now I have left answer A or answer B. So I have to decide which one is smaller, negative 6.35 or negative 19 over 3, which is negative 0.633. So answer A, negative 6.35, is definitely the smallest number. All right, example 5. The table shows the completion times of 4 runners in a race. Joe finished in 12.5 seconds. So he finished in 12.5 seconds. Ellen finished it in 12.09. Steve finished in 12 and 2/5. So if I put 2 divided by 5 in my calculator, that would be 12.4 seconds. And then Patty finished in 12.8 seconds. Which list shows the runners in order by their completion times from fastest to slowest? Fastest to slowest. Now, be careful here, because when you're running a race, the fastest person will have the lowest time, and the slowest person will have the largest time. For example, if you had 2 runners in a race, let's say you had Joe and Andy, and Joe finished the race in 10 seconds, and Andy finished the race in 12 seconds. Who was the fastest? So Joe would be the fastest because he finished in less time. So I want the person, if I want the fastest, that means I need the person with the lowest time. So we have 12.5, 12.09, 12.4, and 12.8. So Ellen is definitely the fastest. So I can get rid of answer A and answer D. Okay, so we have, should it be Ellen Joe or Ellen Steve? So I want the next lowest time. So what I have left is 12.5, 12.4, and 12.8. So the next lowest time would be Steve. So we want Ellen, then Steve. And that concludes today's lesson on comparing and ordering real numbers.